Good morning everybody, myself Acharya Vishvendra, and today I shall be working on modern physics. It's a complete video lectures so that you can optimize your time and energy. So let's begin with the modern physics itself. So the first chapter here is dual nature of radiations and matter. It is composed of 4 topics. The first is introduction, second is quantum theory of light, third is photoelectric effect, and fourth is matter waves. So let's start with the introduction. So initially light was supposed to be a particle or a corpuscle as proposed by corpuscular theory of light, which was proposed by Descartes and further developed by Isaac Newton in his book Optics. The first thing about this is then we have second thing, light as a wave or the wave theory of light. It was originally proposed by Christian Huygens, but it was experimentally proved in 1801 by Young's double slit experiment that light has wave nature. Third aspect is the quanta or photon nature of light, which was proposed by Albert Einstein and Max Planck as well. But Albert Einstein was more concerned about light, the quantas of light, whereas Max Planck was working on a general concept of electromagnetic waves and treating them in the quantum picture of light. So using the quantum theory of light, Albert Einstein explained the photoelectric effect in 1905 and got Nobel Prize in 1921 for the explanation of photoelectric effect and theoretical physics. So this is a brief introduction regarding this. So compiling all these 3 aspects, we can say that light has dual nature. It can behave as a particle as well as a wave depending on the extreme or external conditions and experimental conditions. So that is regarding the introduction. Now let's begin with the quantum theory of light. According to this theory, light is made up of discrete particles or packets of energy called as photons. Suppose this is source of light, it is emitting light. So consider one of the photon or particle or packet of energy which we call as the quanta. Now there are certain points regarding the quantas. First is rest mass of photon is 0. Photons are neutral, so they are not affected by electric and magnetic field. Next thing is photons carry energy and momentum and can transfer them to matter by interacting with them in a collision. Next is in a collision between photon and particle, total momentum and total energy remains conserved, whereas number of photons are not conserved. New photons may be created or old photons or photons may be destroyed. So here it should be noted that number of photons are not conserved in collision between photon and particle. Next is the energy of a photon is